All right. How is it going? How is it going today, you fine people? How is it going? Let's go. Let's go. Appreciate you all being here. Lurkers and twerkers. And sandwich making workers. Turn it up. Turn it up. Dedication. I love the commitment. Mint. Get some mints for your commitment. What? Yeah, let's go, lurkers and twerkers. You guys dropping by, putting up the views. I appreciate you. Thank you for the support so much. I mean that. Followers, subscribers. Well, you all know. You know. Thank you. Ah, man, I love it. I love the support. It's great to have every single one of you beautiful, intelligent people learning along here. We're day by day growing. Yeah, well, I guess we're growing too as well. Grinding C++ code. That's what we're doing. Learning and growing. I am Johnny with Bologna&Weiners coding. Let's go. Yeah. I love it. I hope you love it too. Turn it up. Turn up your turnips. Because they need flipping over. I don't know, guys and gals, just random thoughts, create some laughs, That's what they are. Just finishing up here in chat, doing mod stuff. Never enough time to get this stuff done. I try to allow myself time, but it's just not enough time. So bear with me, please. Allow me to finish up. It's great to have you. Truly is. Thank you for stopping by. We're going to get this done and we're going to get right to learning and growing, improving our minds. Let's go. Drop in some typical usual quotes, to keep you guys and gals motivated and all those sort of things. Right? We all hear, every single one of us, learning, I'm just going to say that in general. We all support you. 100% we do, right? We're all on the same train together. Woo-woo! Choo-choo! Woo-woo! Choo-choo! I know, terrible train, I know. But you get the idea. We're all learning together, contiguously. Let's go. Yeah. Almost done with the quotes. Almost done. Ba-ba-ba-ba. Yeah. What? Yeah. All right. One more. And then I'll check the stream. I feel we're going to be okay. Quickly do that before I close the... And I might shout you guys out quickly. Supporters. Well, I usually do anyways, but... Anyways, hold up. Let me check the stream. I might show you. All right, let's go. Let's go. Let's go. What is this? What is this? Fresh job. Blah, 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 blah. Drop. I don't really play games anymore. I make games. Ha ha ha. At least I think I do. Anyways, let's go. Let's go. Bum, bum, bum. Yeah. Quick shout outs to you guys and gals, supporters, Twitch. You guys are showing up. Thank you, Twitch, for sharing my content. Because you guys are awesome. I should have never left. I should have never left. And I do apologize, okay? The love on the other platform, just not really there. So, I don't know what's up, but I'm not crying in my cornflakes. There's other platforms. Thank you, Twitch. You guys are great. Slowly, you guys are finding the content and subscribing. It's great. It is so great. Much love for the support. I'm going to shout you all out. Dun-dun-dun. Nicole Trace. Bart number 1. Jim Jam. Kazert. Gavin. Kamikaze. ML. Let's go, brother. I Ducky. Quack, quack. Wicked Stat. I know I haven't done that lately, guys. Con Papa's 9. Slow Motions. How you doing, brother? Amir Hassan. Thank you. Kenny M. Gassy. All right. Or, yeah. We're just going to roll that. A Music. Chama. Rough Riders Gaming. How you doing, brother? Low Level RS. So Snob. I don't know, bro. Figure it out. I love that. I try. Ty. Let's go, Ty. Love it. Here's another one that I love. The Absent Present Person. Is he here or is he not here? White and Hood Rich, much love, brother. Thank you for the support. And Fernand Lewis. Fernand Lewis. Fernand Lewis. Thank you, brother. Thank you, mi amigo. ¿Cómo está? Muchachos. Mucho grande. Gracias, mi amigo. I know I'm sorry. I'm working on it. I'm working on my Spanish. Slowly. Yeah, hey, come on. I'm still working on my English. Cut me some slack. Let's go. Nap, Vision, Peter Ann, Caesar Rojas, Tech Dave, WX87, Flawless Hack, Salt of the Earth, Ministry, much love, brother, Ayawi, and Christian Zuler. Let's go. Thank you for the support, guys and gals. Thank you. Yeah. I'm going to stop at the thank yous, but yeah. Yeah, yes, and yeah. Let's go. All right, trying to shorten up my intros. I'm working on it, guys and gals. I am. I do have to go through the same spiel, most of the time. That's okay. I just think of the people, the new people that check out the content, drop by, right? It's new to them, may not be new to you, but it's new to them, right? We are doing C++ over here, guys and gals. That's what we're doing. A higher level thinking language, okay? Non-managed. I love doing coding housekeeping. It's my favorite. Sweep, 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 sweep. I know guys, gals. I could be corn doggish, but who doesn't love corn dogs? Nom nom nom. Let's go. Yeah, so we're doing a class lecture, just to be clear, right? That's what we're doing over here. It's a class/lecture, right? You got that? Shall I say it again? We're doing a class/lecture over here, guys and gals, okay? So if you're looking for that 5-minute video on how to create a variable name and it gets 5 million views, okay, low IQ people, clicking that. But yeah. Oh, I love my digs. My digs are so great. Okay, yeah, so I do export all my content every stream because I want to save it, guys, okay? I want you to be able to continue. Let's say you're just dropping by this for the first time and you haven't watched the series and you've been missing all the content, right? I've got it. Great news is backed up for you on YouTubes, the platform that doesn't share, right? So it's all there for you guys and gals. Bologna&Weiners coding. Check it out. Be great to have you. You don't have to sub. I don't really care. I'd rather you be kind of subbing over here anyways, because I don't know. Anyways, just not feeling the love over there, So, but that's okay. That's okay. My cornflakes are still dry. If you've been following along, you know what that means. Okay, so yeah, it's great to have you. You know what it is. You can stick around, watch the content, the live stream today, of course, naturally. But if you want to kind of learn this language, maybe you're interested, you're curious, right? I'm doing my best to make it easy to learn, right? Doing examples, explaining things, hopefully not over-explaining. Trying my best not to over-explain. I'm a work in progress, but that's okay. I'm enjoying doing this content and also helping you guys and gals learn, right? Because it's not for everybody. And I can see, a lot of people kind of hit the wall with this language. So I'm hoping that's kind of what I want to do. I want to help you actually get it. I want you to learn and I want you to succeed. Okay, that's the goal. Okay, that's the plan. Here to support you. Every single one of us on this, those just like yourself on this journey, all support you. Okay? We all support you. So yeah, over on YouTube, I recommend starting from the first video. I'm kind of mixing it between, audio book kind of stuff in the beginning and then slowly going into doing working with problems and visuals, using Visual Studio, creating visuals. Lots of examples, lots of theory, lots of, just sharing examples, visual examples. And yeah, so We all wish you the best and success on this journey. Once you get back to this video, I'm gonna be like, wow man, it's great to see you again. You've got this far. That's amazing. It truly is. It truly is. You've climbed a lot of stairs to get to this point. Especially if you can tolerate and handle me, man, you're an amazing, strong individual. You are. So we're going to get to this. I know I said I got to try to keep my intros short, but I got to go, explain all these things, which I'm fine doing, right? It's just part of the plan, Yeah, so let's get to it, guys, gals. It is time. Time to put on that old thinking cap, flick the old switch in the cranium brainium. It's time to learn. Leave the dunce caps for the dunce cappers, and let's go. Let's go. All right, where were we? We were kind of working on this. We created a class. We have like an animal class. Hopefully you've been following along. I'll try to recap a little bit. We've created a basic animal class called Animal Cat. I wouldn't probably call it that. It would be like a base class, so it would be just like, I don't know, animal base or something. The reason behind that is because you can have derived classes, and it's all kind of part of, object-oriented programming, polymorphism, and all those sort of things. But we're not getting into that just yet. Okay? Let's just, learn how to create a class and what's inside of a class. What do you need for a class, right? Basically, we're doing what's called the boilerplate code, okay? Enough code to kind of make magic happen, right? So that's what we're doing. We've got a default constructor. We've got a... just rewinding there. Default constructor. Why do I keep saying that? Man. I gotta laugh at myself. My brain's broke today, Bob. I got too many tabs open. What am I gonna do? That's not a mock. I love country people. I do. 'Cause I'm country myself. Let's go. Okay. Default constructor. I guess because I don't like, yeah. I'm just gonna stop. I'm just gonna stop. And we have a destructor. Okay. Inside our source code, we've got some basic, we've kind of put some information in the block of code, which is kind of not the norm. I'm not really a fan of doing this kind of stuff, but I am following a course kind of outline here, and I might actually change it up a bit and show you guys and gals what I call the member initializer list. It's a lot better. I'm just gonna say it looks a lot more professional than this. Okay, this is kind of long time ago stuff. Things have changed and gotten a little bit better over time. Okay, and then we created a print object. All it's doing is a standard cout print statement, nothing special, right? If I run it, which we will, in our main here, we created class name, created an object named Frisky. Again, the object is what makes the magic happen. you guys and gals, if you're just checking out the content for the first time, don't worry so much about kind of the technical jargon and the nameology, if you want to call it that. I like to throw that out. Anyways, I like to call it nameology. Probably triggers some people, which is great. So, again, if you're following the series, you'll get to this point and you'll totally understand, okay? So you just allow yourself some time to grow, right? That's okay. We're doing stack allocated object here. This is an example of a stack allocated. And then we have an example of what we can call newing up. So free store or heap allocated. Okay, stack is static memory, not moving. Heap is dynamic memory, which is basically in motion, runtime. Okay, runtime memory. And then essentially I've used the object to the stack allocated object to print the method here. Okay, that's essentially what we're doing, right? Printing the same method and just showing you different ways that you can do it, right? So now here we have the heap allocated object, right? Newing up, right? Tab. That's what I call newing up. Ooh, I better do this. Newing up. Okay? I got that from my professor. He's awesome. Online professor is what I'm talking about. He's great. Bachelor's degree, he's got it all, right? He's really good man to learn from. Okay, so anyways, carrying on. So I considered this kind of the old school way that they did this. I could be wrong, right? I learned the new school way. I don't like spaces, which is using the arrow operator. This is if you want to use the dot operator, you have to use this syntax to be able to use the dot operator. This arrow operator replaces basically the dereferencing and the brackets. That's what it does. The arrow pointer also dereferences. Okay, you have to watch the pointer series to understand what I'm talking about, guys and gals. I'm not going to keep explaining, right? Because there's a lot of individuals that are following this series. They're up to par. We're all hanging out playing golf together and having fun. Okay, we need you guys to catch up. Okay, we need you to catch up because we all want to play golf together. It's going to be a good time. Truly is. Okay, don't forget to buy me coffee so that we can all play golf together because I look forward to it. I truly do. It's going to be good times. And there we have it. So let me build. Well, I already built, but I'll just do it anyways. And run. There we go. So we're just printing the same print statement, print method 3 times. Okay. This and this are the exact same thing. Okay, just so you're not confused. Okay, it's just 2 different ways of doing the same thing. All right, clear as mud. I hope so. I haven't said that in a while. I don't want it to be clear as mud. I want it to be clear as transparent window. That's right. All right, I'm gonna get rid of this. Okay, And what am I going to do here? So we're going to keep moving forward. Don't forget to delete, right? When you're newing up, you must delete. If you notice, I'm deleting the pointer, Frisky. Okay, that's what I'm deleting. All right. Let's see. Frisky is created as a regular local variable, thus is created on the stack, which is this. Okay, you can look at it like a local variable. In essence, The syntax is very similar to creating, an int variable or whatever, right? Except this is a class variable, but we call it an object, right? Thus, it is created on the stack. This creation causes the constructor to be called, right? Like I was explaining, I want to kind of go over this really quick. I didn't mean to go over this again, but it's kind of recapping, I guess. Right? We don't need to. This is a default constructor. This is the syntax for it, okay? We get it for free. We don't, technically speaking, we don't need to, right? I could comment it out. I'm still going to get it. It's the program, whichever it is, gives it to us for free. We don't have to call a constructor. We don't have to do any of that stuff, right? It's given to us for free behind the scenes, okay? Or another way to say it, under the hood. All right, so I could build it and I shouldn't have any issues. And I am, let's see, 13 it's saying? What? Where? Oh, CPP. Okay, let's go there. Yeah. Here. I have to comment this out. That's why. Okay? That's why. All right? When you do, I'm being silly. I need more coffee. I need to wake up a little bit to teach here. See, I commented it out in the header class, okay? So in the CPP, which these two are linked together. They belong together, okay? This is reading from this, okay? They're linked together. I commented the one out. I have to do the same with the other, okay? Control KC. All right, I'm being silly, okay? There we go. Be gone. And I can run it. I still have my object I created, right? I don't have to go like this to say I'm calling the default constructor. It's not necessary. Okay, let me run this. Shouldn't have any issues. Okay, we did get the destruction of it. The reason you're not seeing the dots is, well, because we're not really printing it, right? And plus I commented it out, right? So that's why you're not seeing the ... Which this is my representation of an object kind of being created in a sense, or calling our constructor, however you want to look at it. Okay, that's why we're not seeing it, because, well, it's commented out, right, guys? Can't see what's not there, right? So, but as you can see, our destructor is being accessed. Okay? All right, let's keep moving forward because we must. All right, I don't want to waste too much time recapping here. Control KU and run. Okay? What? Did I not do that one? Oh. What am I doing here? Wake up, Bob. Wrong one. Okay, there we go. Go away. Be gone. Be gone. Okay, build. Run. Oh my goodness gracious. I need glasses for my glasses or something. Let's go. Okay, I need to move forward on this. Let's keep moving forward. It's kind of a recap. Let's see. Okay, this creation causes the constructor to be called. I've been kind of reading from the course outline, and I just kind of bounce around and get distracted. Explaining things which I'm kind of already reading, but anyways. The simple cat pointed to pregs is also created, right? This pointer is pointing to, well, we haven't actually equaled it to the memory address, so it's a bit different. Because the pointer is being used, it is created on the heap, right? Essentially, this is what we're doing. We're creating essentially a new variable on the heap, That's what we're doing. It really isn't directly connected to this at all. But we still have to delete because we are newing up. This causes the destructor to be called and the memory that has been allocated to hold the simple cat object to be returned. When the function ends, Frisky goes out of scope and its destructor is called. All right, accessing data members. Excuse me, guys. Let's see, where are we? So we've been working with the dot operator. You've seen that. Did I go over a definition at all on that? I may have. I don't recall. Let's go to my C++ reference guide that I've been creating. Slowly creating. Okay, I am looking for dot and there we go. Just gotta go to the section. Went too far. Did a little bit of organizing last night to kind of speed things up. I just went too far here. Okay, where are we? All right, so I'm just going to share this. Let me just go like this. Okay, whoops. Well, that works. Whoops, what? Where'd you go, Batman? Get back here. Okay, there we go. All right, so I'm going to let you read that, okay? Some examples, general detail on the dot separator, which we've been using. Okay, I've showed you some examples. And I've also showed you can pause and just kind of read if you'd like. I would read it, but I want to kind of keep moving forward. I want to keep this train rolling, okay? And then I have the arrow operator, okay? Basic definition, functionality, and all those sort of things, okay? All right, perfect. Put that in there. Accessing data members. As you should be aware, this works for cat objects created locally. Okay, this is locally. We're in the main, so it is created locally. To the main. That's what I call it, to the main, right? Accessing the member of an object when you use a pointer is a little more complex. I've already showed you, right? You just seen the example. I'm kind of a little bit behind here in the readings, so we'll try to catch up. We're kind of going over dot operator and the arrow operator right now, guys, okay? To access the cat object or the animal cat object, which is Frisky, on the free store, which is dynamic memory, also known as heap memory, or on the heap. You must dereference the pointer and call the dot operator on the object pointed, right? Recall what we did earlier, right? Okay, to be able to access, right? The dot, this asterisk is dereferencing. So to be able to use the dot operator, that's the syntax. Okay, that's kind of what we're going over right now. I'm trying to get through this, get caught up here to where we should be in the course outline, okay? Thank you for understanding. You're amazing. You then use the dereference, the value being pointed to, along with the dot operator to access the members of the object, right? These are the members, okay? We could actually access the destructor, but it's not really something you would see people do, because it actually is done for us anyways. We don't need to call it, right? The purple squares in Visual Studio are methods. Purple cubes, I mean. So if you see a purple cube, it is a method. Let's see. Therefore, to access the print statement, member function, right? print object. It is a member function because it's a member of a class. It's part of a class. That's why it's called a member function. In turn, it's also called a method, right? It's all the same. An object pointed to by blah, blah, blah. You write that. As you can see, parentheses are used to ensure that the pointer is dereferenced first, right? That's the reason for the brackets. It's like an order of operations thing. Think of it like bedmass, pedmass, okay? It's not, don't overcomplicate it in your mind, okay? You just need them, right? Order of operations. Before the print statement is accessed. Remember, parentheses have a higher precedence than other operators. I feel like I kind of went over this already. I do apologize. Because this is cumbersome. Yeah, I kind of have already. So then I read the pointer stuff. Now let's do this. I got rid of this. Okay, we've talked about the pointer a little bit. Remember, we called it a class member access operator. If you need to refresh on that, just go back to the prior video, because I know I just recall I've already read this. A little bit of a brain fog today, guys. So, all right, let's go back to here, and so they've done. Which is kind of, I don't know. This is a bit, I don't want to call it old school. I don't. There's a better way to type this code, but we're going to do it like this. So they have its age equals 2. All right. Just so we could actually see a different number value. There is another way to do this, and I'll show you. But I want to just do this the way they've done it and just kind of run it. And if I have to fix it, I will. I have no issues doing that. All right. Let us try their way first. All right. So we need, what I'm going to do is what is called accessors, setters, and getters. Okay. That's what we're creating now. Okay. I do these kind of like, everything's in order, right? In sequence. Okay? So they have a int get age and a void set age. Okay? And the reason for that is well, we only have one private variable. It's the age. So we're going to create setters and getters so that we can access this variable. Okay? That's what we're doing, right? We're making the connection, guys and gals. That's what we're doing. Okay, go to the H. And then I need to go like this and like this. All right? Let's create these. Okay, int. Let me just see here something. What's my order? Int is fine, I guess. Yeah, an int is fine. And then get, then set. That's the order I like to do it. Get, then set. They have uppercase. I usually use lowercase. That's up to you, okay? All right? I'll just follow what they have. And then brackets, right? Because it is an int function, okay? Int method in this case. And because we're trying to retrieve information, right? We don't want to change the information. We want to retrieve it and bring it back to wherever we need to take it and make sure it's unchanged. This is why we add const. Okay? So I'm going to close that because this is the syntax for creating it. The next thing is the set. The set age is modifiable. Okay? No const, because we want to be able to modify it or change it, right? A lot of times you won't see these used because through the main, then you can modify values, right? So no const, okay? No const, but it does need to take in an int, right? It needs something. At this point, we can also add the ampersand. Their code doesn't show that, but I'm going to add that. And that's the syntax for it, okay? Let me close this program. Okay. And then I'm going to create declaration definition. Now I'm going to my source code. Where did it put it? It's right here. Okay. It doesn't know where to put it. That's all. And it puts it close to the last thing, right? That's normal. Okay. There we go. Okay. So going to here. Let's do our syntax. So we're going to return, this one again is const. So we go to here and we use our private member variable and we return that. Okay, const means it's going to be returned unchanged, unmodified. So here I need a variable because we're passing in, right? From the main, int main, we can pass in values into this set age. And of course I got that all messed up. Let me fix that. Quick fix. Okay. And then I'm going to call it, I don't know, its age. I'm going to just go like this. I usually go with lowercase because if you've been following the series, you'll know I kind of cringe when I see variables with the same name or they're typed the same. I guess I'm up for the challenge myself personally, reading other people's code and deciphering and kind of organizing it in my mind. What are they doing, right? I've actually read other people's code like that. It's like, man, what is what, right? And it can be troublesome. But once you figure it out, then it gets easier. It actually helped me learn a lot, to be honest. Okay, so we got to make left-hand side equal right-hand side. Okay, that's what we're doing here. We're passing. We're passing whatever comes in is going to be the right-hand side, and we're leapfrogging it to the left-hand side. So we have to pass it to our hidden variable, its age. Okay, there. That's it. That's the syntax for a setter and getter. That's it. That's simple. That's it in a nutshell. Pretty simple, huh? Give me a sec and let's do this. All right. Let me build. So now we should have actually access to the get age and set age through the main, right? Because if you notice, they are still public, right? All of this inside here, right up to here, right, is all public. Okay, I haven't showed it, but right up to here is all public. Okay, so anything between is all public, right? Makes sense? As soon as we get here, it's private. I can create more variables if I want. Let's say I want its weight now. Okay, and I'm going to initialize it. Right, so it has some value. I can initialize it in other ways too, but there we go. So now I created its weight and its age, right? So each new variable that you create here in the private, well, most likely you're going to want to also create setters and getters for those, right? So it's the same thing. I could do them quickly here. Okay. Okay, there we go. Boom, that fast. It's all, the syntax is all the same, guys. Just change the variable, the method name. Boom. Go back here. Boom. Okay. And then we're going to go here. Okay, I don't mean to go through this fast, but there, right? Same thing, same syntax. Boom, 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 boom. Go like this. Its weight. Go like this. Boom, 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 boom. Beep, pop, boop, bop, 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 done. That's it. Look how quick that was. That was pretty fast, wasn't it? I can go fast, I guess, sometimes. All right, so now I created a getter for the weight, a getter for the age, a setter for the weight, and a setter for the age. That easy. Okay, I just added that in. Now it's not even part of the it's not even part of this course outline, but I'm just adding it in. Now they have, this is their syntax here, right? I prefer the member initializer list, and also you can default your whatever you're passing in. If you have a default constructor with a parameter list, you can pass in default values doing it that way as well. All right, let's go to the main and access that information. So I could use, am I getting rid of the, yeah, so let's get rid of the stack allocated. Okay, we're just gonna get rid of it. Stack allocated, love you, but see ya. Okay, we're just gonna new up. Okay, we're just gonna new up here, guys and gals. We're just newing up. All right, I'm gonna build. Okay, because we have a pointer. I'm still gonna call it a pointer. It doesn't matter regardless, right? Really, it's just it is a pointer. It still is, and we're newing up space in memory for the dynamic memory, right? That's what this is doing. Because we're doing this, we're newing up. You must delete, right? You must also call delete, okay, on the object. All right, that's part of the housekeeping, guys, gals. Just remember that, right? Be consistent. I always say this, right? Now you have a better understanding between what a stack allocated object looks like and what a heap allocated object looks like, right? I'm helping you understand the differences. You can look at other code and go, oh, that's stack allocated. Oh, that's heap allocated. You can tell just by looking, right? I'm here to help. I don't think any other channels are explaining this sort of stuff, but anyways, they show you, right? They're good at showing. Okay, anybody can show, but can they explain? That's the difference, right? I try to do the explaining. Hence why my videos are a little longer, right? Because you're actually learning. Okay, I could do a 4x speed video and just spam out code and go, there you go. Oh, God. Okay, I'm going to stop. It's a head shaker. Head shaker. It's one of those how to create a variable type videos. All right, so we've done that. We only have one object this time now, guys, right? I got rid of the stack one. It's gone. Bye-bye. So let's see. Let's go like this. And you can do this sort of stuff, right? It's not really... we can getting information's fine from the main. Normally I would throw it into a print statement, but we could do this as well. So watch this. So I'm gonna go Frisky is, and we're just gonna do this in code. Okay, Frisky is, and then we're gonna call, right? We gotta call P Frisky. Okay, get my variable. There we go. And because we are using heap allocated object, we're going to use the arrow operator. That's the only way you can access it, guys. Okay? Well, it's not the only way. Sorry, I don't mean to say that. This is the other way, right? But again, the difference is now you're using the dot operator. That's the difference, okay? Does the exact same thing, syntax is different, that's all. Arrow operator, much quicker. Okay, so now we're going to access the get age. It is a method, so you still have to, this is the thing that you have to do. You still have to type the brackets. And then we're going to go like this, years old. Okay? Remember, we hard-coded it. Well, I don't mean to call it hard-coding, but we, technically speaking, did. I'm going to take advantage because I have a string literal here. This is my tip and tricks to you guys and gals. Standard end line is it's good if you want to clean the buffer. I have kind of at the end here cleaning the buffer. Okay, for the most part, I usually at this point I'll either use \n, or let's say I wanted 2 enters, I would use double quotes \. Okay, but here, let me show you some. Because this is a string literal, why not just go like that? There you go. Take advantage of your string literal. That's what I say. Okay, and then I could actually set through the main. It's kind of frowned upon, but just to show you, you can do this, right? Let's say all of a sudden, it's a miracle, it's magical. Our cat just went, you know what I mean? Now the cat's next year all of a sudden. I could be silly and do stuff like this. 8 years later, kind of, like a SpongeBob kind of thing, right? And then what's 8 plus 2 is 10, right? 8 years. Oh, I didn't even type 8. Nice. Okay. There we go. Okay. And then I'm just going to reprint the exact same thing. Boom. Okay. So this is the before. Excuse me. And this is the after. Okay. Makes sense? Right, before the change and after the change. Again, setting in the main is not one of those fan favorite type things. Normally, I don't know, setters usually are not created, but this is all part of the learning. This is just another tool in your toolbox. Something that you can do, right? If you're at home doing this kind of code, by all means, you could do this. Okay, it's your home, your house, your code, your program. You do you. Right? Nobody can tell you what to do. All right? And then make sure you don't forget, right? This is important right here, okay? Don't forget to do your housekeeping. Housekeeping! Housekeeping! Can I fluff your pillow? I love saying that. Okay? Because we are newing up. Because we are newing up. That's why. All right, let's run it. It'll print line by line. It'll print all the statements. What am I doing here? What did I do? Oh, syntax, right? It's a syntax thing, isn't it? What? Oh, is it because of my, yeah, okay, because I'm passing by reference, that's why. Okay, I have to point it and do all that, create a new variable. I have a workaround. So I could go like this. I have a workaround. Let's see, let's go. This is where you start. This is how you start learning how to use pointers and stuff. I gotta make this work. Okay, so I have to pass in, but then I would be passing in a, dangity dong. If I use a pointer, then I have to pass in a memory address and then dereference it in my code. I don't think I could do that through my, normally you can hold up. Where are you? Okay, should be able to pass by reference. I don't know why it's being like this. Okay, hold up. Void animal cat set age cannot convert from one. yeah, it's basically saying, so, you know, um, I mean, I guess I could still do that. Go new age, into new age. What's up? Okay, equals 10. And I could easily pass in the new age here, right? Using a symbolic constant instead of a hard-coded value. And then here, what I could do is I could actually create a pointer. Might work. Let's see. Pointer P new age. And then it's going to equal the memory address of new age. And this should work. So instead I'm passing in this. Okay. Right here. Okay. There we go. All right. That should work. Let's see. Cross my fingers. Int to int, pointer int. Yeah, why do you have to be stubborn? Oh, right. I'm being silly. Okay, dereference. I have to dereference. There we go. Yeah, be gone! Be gone! Okay, there you go. Now you guys know through code how to do this. Okay, I'm just kind of my brain fog today. But again, it didn't take me 8 hours. All right? It didn't take me 8 hours. All right, let's drop the yays because we can. I like these kind of things that pop up because you guys and gals, again, look. I got the award. Because I push through and I persevere. I put in the time. Okay, I don't rely on other things to give me the answers. I use my own brain molecules to figure things out. It's just who I am as a person. Like it or love it. I'm proud of who I am. I could give myself a pat on the back because I put in the hard work, the time, the effort, and I earned it. I earned it. Earned it. Okay? Let's go. Okay, carrying on. Thank you for being here. Love you. But now you're learning from me, right? My pain is your gain, right? Now you know how to actually use, right? We're actually passing by reference, right? Okay, passing by reference. I have to pass in a memory address, right? Actually, it's a value, but the way the code works is kind of a little bit jumpy, but I have to create a variable. I make a literal constant, okay? And then I create a pointer variable that equals the address of my new age variable. You can see that. And because I have to set age with a value, right? Because it's an int, right? It's an int, passing by reference. It is an int, so I have to pass in an int, right? Hence why I have to also dereference, right? That's called the dereference. I should have this down here. Where is it in code? What do they call that? Where I mean my course outline. I just want to make sure I call it. I know what it does, okay? I know what it does just by looking at it. This is just what it's called. I don't care what it's called. I know what it does. I know how to use it. Where is that? Okay, let's see. See if we can find it. I have to kind of go back here in the readings. I know I had written it down, but I wish I didn't move it or delete it or whatever I did. What do you call it again? I know it's dereferencing something. Dereferencing, I don't know, my brain, too much information, too many tabs open, bit of a headache, need more coffee, a lot of excuses, okay? Dereferencing Oh, I might have it actually somewhere in my notes. Oh, D referencing. I don't want to call it a pointer because it's not a pointer, right? Let me see. Let me find my notes here. Let me go here. Let me go here. Let me go here. Let me go here. I think it's in here. Or is it in here? Where did I put that? That's in here. Yes, it is in here. Okay, is it this one? All I have is an asterisk on the left-hand side of a variable. It means dereferencing. Okay, that's what I have for notes. Okay. Right. I could give you that. Right. An asterisk on the left-hand side of a variable means dereferencing. I don't mean to call it left-hand side, but as you can see, it's on the left-hand side of the variable, the pointer. I do apologize. I have to read all this to try to find what they called it. You guys know what it's called, don't you? You're probably telling me, you're like, it is called this. I remember what it's called. Man, you're awesome. You're amazing. You remembered that. Bear with me, bear with me, bear with me. It's not too far in the lecture here. I don't know why I can't find it quickly. Maybe I have to scroll up further. Could be. Yeah, that's what it is. It's up a little higher here. Okay, we're scrolling back a little bit here. Is it here? Wow, we're really moving up. There we go. I might have found it. I might have found it. Maybe. Indirection? Yeah, that's why I didn't remember that. It's such a weird name. When the pointer is dereferencing, the dereference or indirection operator, that's what they call it, operator. Why can't I think of the word operator? Oh my god! It is an operator. It is an overloaded operator. Yes, it is. In fact, it is. Operator. Okay? I'm typing these notes because I don't want to have to keep going back and forth and doing this. Indirection is another word they call it. Let's go like that. Okay? There. Okay, let's move forward. Let's get back to where we were and keep going. Okay, there we go. And build. Okay, we're fine. Okay, code's working. So yeah, guys, right? Now you can see how it all works, right? Now you're actually to the point where you're utilizing and seeing where this stuff is used in code, right? That's kind of the goal. There's no sense teaching you all this and not showing you examples, right? Another reason why my brain was saying pass by reference here, right? I'm showing you kind of right from the beginning instead of like, because I could show you, I could take the easy route and make myself look like I'm really awesome and good at this stuff by not doing that, right? I could easily do that. I could fake it, right? I could fake it like, anybody else that maybe does this kind of stuff. They're just showing you how to pass in an int. Ooh, wow. Oh, yay for you. Insert seal clapping here. So the point is I'm showing you the right way to do it right from the get-go, okay? Without shortcutting the system or faking it, okay? All right, I'm the real. That's right. That's probably why I'm not so popular, because I'm just, right? I don't know, it's tough love. I love you guys. I do, right? I would still have your back, okay? Who do you want to have your back? Me or the fluffy cake that lies to you? Who is it? Who is it you would rather have your back? Okay? You trust fluffy cake? that lies to you to have your back? Man. Okay, let's run this. There we go. Boom! 8 years later. Let's drop the yays. I should put an enter right here. You can see we have one object. Our constructor is being called. And then in fact oh, look at that. So maybe yesterday when I was thinking that it's kind of an order of operations thing. The newing up actually gets deleted before, right? Which makes sense because I'm calling delete here, right? I should have clued in yesterday's stream, and that's a correction, okay? I'm going to correct myself from yesterday's stream. Remember, I created the one that was on the stack, but I just recently deleted it. It was actually deleted after, okay? So the newing up one gets deleted first, okay, when it reaches the empty scope, okay? The newing up object gets deleted first, then once it goes out of scope, then the stack allocated object gets deleted, okay? Just to be clear, all right? I'm noticing the subtleties now. It was harder to tell which one was being deleted first, which logically makes sense. I'm actually explicitly calling it right here, right? So I was being a little silly, but that's okay. All right, so now you know, right? The newing up. If you're not sure and you don't remember, just go, oh, look, I'm calling delete first, right? So it's going to do this, right? That's our destructor doing its magic. All right, that's the reason why I create these empty scopes, so you can see that magic. All right, our destructor being called. Okay, the object destroyer, that's what I call it as well. Okay, so I needed a backslash here because I want an enter, because once it creates the object, I want to kind of drop this line down. And then I want to create a couple of, let's see, where do I want this? Right here. I want a couple of enters right here. So let's build it and run it again. Okay, so you can see. All right, there we go. Frisky is 2 years old. Insert SpongeBob. 8 years later. You guys get it, right? Frisky is 10 years old. Whoa, wow, yay. Let's go. All right, let's keep moving forward. I'm kind of following the course outline, but I'm also adding in my little take and nuances and stuff as well, guys and gals. Okay, so bear with me. Let me get back to where I was in code and get caught up here. There we go. So yeah, Frisky's now 10, right? And then I created this object, right? That's why I have this local variables, local to the main. This is where I do create my variables, okay? All right. You want to create it ahead. It's a local thing, right? The code needs to see that. So therefore it needs to be above it. Make sense? All right, I don't want to go into details on all the stuffs. You guys get it, right? We talked about the dot. We're using the arrow operator because we're newing up. That's why we're using the arrow operator. A lot of people might get confused, right? They're like, oh, I don't know. Do I use the dot? Do I use the arrow? Right here, Johnny with Bologna&Weiners coding is showing you right here. Let's go. Creating member data on the free store. Okay, here we go. This is where we are now. Just give me a sec. There we go. Creating member data on the free store. In addition to creating objects on the free store, you can also create data members within an object on the free store. Okay, what are they talking about? Let's see. Oh, they're using pointers in their code, so I'm kind of jumping. So, okay. All right. We're going to switch it up. We'll show you the other way. So, right, I showed you passing by reference. We still have to dereference and all those sort of things. But there's the passing by pointer reference. It looks like they're leading into. Okay, let's see. One or more of the data members of a class can be a pointer to an object on the free store. Using what you have already learned, you can allocate memory on the free store for these pointers to use. The memory can be allocated in the class constructor or in one of the class methods. Okay? All right, let's see how they do it. When you are done using the member, you can and should delete it in one of the methods or in the destructor. Okay, let's see. Pointers as data members. Okay, accessing with the arrow operator. Okay, so that's kind of what we're leading into here, right? So I'm just going to go like this. Pointers as data members. I could, whoops, didn't mean to do that. I hit F12, I'm glad nothing happened. Okay, there we go. All right, I just want to see, yeah, we're good. All right. I'm going to, let's see, okay, let's go here. I might have to kind of get rid of all this stuff, right? Again, not using stuff is bad. Again, you're making copies, right, guys, gals? So if I do it like this, it's cringe what I'm doing here. It really is. It would still work, but remember I'm creating copies at this point now, right? Make sure I also update it here. I have to remove it here as well, right? Remember, they have to match. Okay? So I'm gonna build it. It will run, but it's gonna create copies. Okay? It still works, right? Still kind of fast, but you just duplicated. Well, I don't want to call it duplicated your memory, but you got a little more going on under the hood. All right? So they are in their code. They are doing it this way. Okay? Let me look. Int age, get age. It's a const, and they're using the pointer here. They're dereferencing here, which is telling me that they're passing by pointer reference. That's what I'm going to get from this. And then with the set age, it's the same thing. Okay? I'm going to just do it for the other one as well. Okay, this is the other way of doing it. All right, guys? Hopefully we can get the magic to work. And then int get weight. Oh, they added the get weight too. Yeah, they did. All right, let's see. Delete its weight. Oh, okay. Yeah. We got to make sure we do that. So now we're going to actually take advantage of the destructor. This is what they're doing. So instead of doing it here, okay, I could actually go like this. I'm going to get rid of this. I know, kind of cringe, I know. What is, oh wow, I got a lot of enters going on there, don't I, guys? Woo! What is up? Let's get rid of that. Going back here, we're adding a little extra code, okay? I know I'm jumping around, but just pay attention which one I'm in, right? Header, source. These two belong together. Okay? This is our declaration. This is our definition. All right, so in the definition with the destructor, we're going like this. I'm going to go here, and I'm just going to copy this because I'm kind of being lazy. I'm going to go like this, and I'm going like this, and I'm going like this, and I'm going like this, and I'm typing delete. Okay, you can do this with your destructor. Okay, so now we're actually using the destructor to delete. Okay, And I know it says nothing here. It should be nothing here, but whatever. All right, so far so good. What else do they have? So our private also is a pointer. I know there's a lot of pointers going on. This could get confusing, right? So this is the passing by pointer part, okay? And then in here, we are dereferencing, okay? This is the, right? That's why people get confused with this stuff. It's because of that. You have to understand what like, look at each asterisk as the top of a human head. You're a bird flying around and you can see the top of a human head, okay? Pretend it's a person, okay? You're flying above, whee! Okay, this person is doing a different task, okay? These two are doing the same task while they're in the same area. So they are here, actually, I should set it up the way I like to, just so it's less confusing. Okay, we're passing by pointer right here. Okay, this is the pointing. These guys are the pointers, the ones standing in the street pointing. All right, and then here, these guys are dereferencing. So they're different people, okay, doing a different task. So I have to make sure. And then up here in our, okay, yeah, and here as well, right? Because we're returning, we have to return the value, right? So that's what you're doing. We don't want to return the memory address, we want to return the value. Okay, that makes sense? That's why we're dereferencing here. Okay, this is the value, right? We have to make a value equal a value, right? It's a, like I said, I like to say, compare it also to a teeter-totter, right? Left-hand side has to equal the right-hand side. If the left-hand side is a integer, the right-hand side has to be an integer, right? You can't go left-hand side's a memory address and say it's equal to an integer. Okay, that's, you just broke your brain. Okay, I hope that makes sense. Okay, let me just double check. So in their return, they're dereferencing. I know there's a lot of extra, right? But as long as you understand what each thing is doing. Okay, and then in our private, these are the pointer guys. Okay, and inside the constructor, they got a lot of weird stuff going on. This isn't the way I do things, but I'm just kind of following what they do. So here's where they're newing up. Okay, this is where they're newing up. Okay, so this is where they're doing the newing up. Okay, new, int. Okay, and then they're hard coding it, right, with a 2. Okay, this is the newing up inside our constructor. Okay, same thing with the weight, right? And we're going to new up as well. Okay, this is the newing up. And that's the reason why we're deleting here, guys and gals, because we're inside the actual class itself, okay? Right, we're not in the main. So the code we type in the main is different. I should get rid of all this. I'm not sure what I'm going to need in the main. We'll see. I'll fix this up. Okay? So we're kind of doing another way of doing the code here. Okay? Again, the example I initially showed you was how to do it when you're passing by reference. This is passing by pointer reference. If you have to follow, you have to watch my pointer series to understand. Okay, I feel like this first video, I feel like I explained it really well and nicely. The second video, I might have been a little bit more firm. If you look at it, I might have been a little more tough loving, if you will. But I still also, I think I get the point across. Okay, you have to see it. Okay, get your coffee. You know, make sure you gone to the washroom, sit back, relax, and just have an open mind, learn and enjoy, right? My approach, I try to be nice. I try to be tough, lovey, right? I want you guys to learn. I want you to succeed, okay? Life isn't all flowers and cupcakes, okay? All right? It just isn't. All right, much love. Let's keep going. So now we're going to go into the main. Okay, hopefully I got everything done. We're newing up inside our constructor. This isn't common. It's just a way you can do things. It's a bit old school. But we're just learning here, right? Okay. So normally I do these kind of things in the main, but that's okay. All right, let's go to the main. And what do they have? Okay, so we're newing up. And okay. And then same stuff here. This isn't changed. Okay, this is good. All right. And then they still have the set age. Why though? Why would you set the age again? To 5. Okay, so what do we have here? Age is 2 right now. Okay, I want to try to run it without all this extra code. So I'm going to go like this. Just going to comment it out. Instead of... okay, we're just going to comment it out. I want to run the code before. I want to see what kind of answer we get. I should be, if I've done this correctly, following their little kind of, it's a bit of a mess, right? But I have the ability to kind of do the workarounds with it and try to make it work. All right, let me build it. All right, no errors. That's a big yay. Okay, I haven't missed anything, so that's great. And so going back here, age is 2. So I should get 2. Okay. Again, we're calling the constructor. It should access whatever information is inside the constructor. Let's find out. Okay. Control F5. Let's go. 2 years old. Yeah. Let's go. Okay. So as long as you've done the steps correctly, you're going to be fine, guys. It's just another way of kind of managing your memory. Plus, you're not duplicating. Okay, you're pointing. You're saying, hey, the information you need is over there. That's what the pointer guy does, right? That's his job. This guy here is saying, he's pointing. He's going, the information you need is over there at that address. Okay. Now looking at our setters, okay, there's nothing in here, right? Right? There's no symbols, so pay attention to that. The symbols are inside because we want to return the integer. That's why we're using this guy. We're telling it to return the value. I hope that all makes sense, right? We're kind of, so you got to think of it this way, like a pointer holds an address, right? We want it to return the integer. We don't want it to return the address. That's why we're basically, I don't want to call it transforming, but converting. We're doing the switch, kind of like a knot. We're flicking the switch. We're flicking it from a memory address return to an integer value return. Look at it that way. Okay? This is flicking the switch. Otherwise, it's going to return a memory address, but it'll actually break because a memory address, technically speaking, is an integer, but not really. Okay? All right. And so there you go. That's the code. Okay? Again, the setters and getters, right? The setters and getters. Go go like this so you can see. And then we're also deleting. So if I run it, we should see it's not printing out our delete. Why? I just noticed that. It should be calling this in the main. So this is another reason why I don't really like this. We created the object, we're newing up, but we're not deleting. Are we cleaning up the memory? Is the question. So behind the hood, it's deleting it, but it should still be calling I should still be seeing this. This is what I want to see, right? And I'm not seeing that. Okay. Under the hood, is it deleting? I don't know, guys. I certainly hope so. I feel like the delete command isn't being, called, right? Again, I'm not a fan of this way of doing things. It's just another way of doing things. Okay, this isn't the way I do things. I have a scope that I set up for deleting. It's a class in itself, and it's effective. So, yeah. Let's just move forward, okay? I have no answer for why I'm not seeing that in code. Should be seeing it. I can see the constructor, but I don't see the deleting, right? If you shut off your computer or your system, you're going to be fine. That's when your RAM gets cleaned up too as well, guys, okay? When you turn it back on, things are fresh and new again. But we may have stuff dangling in memory that we don't know of, okay? Again, there's lots of memory there. The program could still access other slots in memory. But again, we have that space that's not cleaned up, right? Okay. They have kind of a breakdown on this, but I'm not going to read it. It's saying here, when Frisky is deleted on, where's the line here? Oh, there's still, they do still have, they've kind of, okay, this is on me now. This is on me. Aha, so I'm not being explicit. You still have to, I just seen it in their code. Okay, I was under the impression that the destructor was going to do the cleaning up. Okay, maybe does the delete command call the constructor? Probably, if I'm to think of it. Yeah, so because they have delete in the main, they do. This is still here. Okay, so that's on me, guys, but I'm kind of thankful that I caught it. Okay, just gonna go like that and say that's together. They actually have the delete command still in the int main. All right, little details. And again, that's on me making the assumption that the destructor is doing its job under the hood without, because right, it's for free. It's the for free concept. If you understand what that means, right? A default constructor comes for free. That means we don't have to do anything. We don't even have to think. It comes for free. It's given to us. It does things for us automatically. With that said, I look at the same thing with the destructor, the same analogy, same concept, right? Because they put this in here, my mind was thinking, well then, because I was thinking, well, it's going to be called automatically. Okay, that's what my mind was thinking, that it's going to be called automatically without me having to do anything. Again, not making 10,000 excuses, but at least you guys can see it, right? These things are good because it's helping you learn and get better, right? So be aware, you still have to call delete. Okay, so I'm going to do this, and that must call the destructor. So I'm being explicit. This is being explicit. Explicit. You'll hear them terms. Implicit and explicit, right? Those are actually words for the day. Implicit and explicit. Whoops. I'm just going to type it because I don't know what I just did there with my fingers. Okay? Words for the day. You can research them if you like. So I'm going to run it and we should see it now being called. Perfect. Let's go. Whew! How are we doing for time? Okay, not bad. We still got 20 minutes. All right, I'm glad I seen that. That's good. I'm glad I seen that. Okay. Explicitly calling the delete keyword. Okay. It's still there. And I'm happy that I seen that in code. And you guys understand what I was thinking, right? I hope. Okay. All right. So I'm just kind of reading their stuff here. Kind of glad I was reading a little bit. So when Frisky is, that's what caught my attention, because it says when Frisky is deleted on line 41, and I went to line 41, and I'm like, oh, right? Seeing that they had it still in their code. I missed that when I was looking at their int main. All right, the destructor deletes each of its member pointers. If these in turn point to objects of other user-defined classes, their destructors are called as well. Okay, there you go. That's the fix. Don't forget to add the delete. Okay, don't delete it like I did earlier. Keep it there, guys. Keep it there. Always keep it there. How about always keep it there? All right, I'm going to show you this other scoped class that I can create that actually does the managing for you. It's just another way it's done. So many, it's just like anything, right? There's different types of hammers, right, to do the same task, right? Makes sense? Understanding what you are accomplishing. The use of pointers, as was shown, would be pretty silly in a real program unless a good reason existed for the cat object to hold its members by reference. Yeah, this not really, with that said, this isn't really the way I do it, right? This is a bit new to me. Okay, that's okay. I'm open to learning different ways, but they're saying here that would be pretty silly in a real program unless a good reason existed for the cat object to hold its members by reference. And that's what they're doing. Yeah, they're holding the references by, right? I've never done this before. So in this case, there is no good reason to use pointers to access its age and its weight. But in other cases, this can make a lot of sense. This brings up the obvious question. What are you trying to accomplish by using pointers as references to variables instead of just using variables? Understand, too, that you must start with design, okay? If what you've designed is an object that refers to another object, but the second object might come into existence before the first object and continue after the first object is gone, then the first object must contain the second reference. right? I think what they're referring to, guys, right? Because you're hearing the words object twice, right? In the sense, when I create a pointer, right? Technically speaking, I mean, I think that's what they're referring to as another object. In this case, I'm ampersanding it to, you know what the ampersand does, right? You should know, right? Okay, that might be the other object they're talking about. I'm trying to analyze and understand their kind of theory and lecture here as well, guys. For example, the first object might be a window and the second object might be a document. Okay, different analogy going on here. The window needs access to the document, but it doesn't control the lifetime of the document. You'll hear that. That's something else that you'll hear. That's even more words for the day, right? You'll hear lifetime of an object or even a variable. Lifetime of an object, right? That's another reason why passing by reference or passing by pointer reference, that's the key concept with doing that, is because we want to keep the lifetime of a value, let's say stored in New Age. We want to keep that from being destroyed. We want to keep it going continuously. We want it to survive longer in our code instead of it going out of scope, in the sense, right? Because as soon as int age, as soon as it gets here, it goes out of scope, right? You have to understand, right? The sister bracket does the cleaning up, especially with, this is a stack allocated variable, okay? You have to understand what is what. Stack allocated variable, right? It goes out of scope, right? Right? We're continuing the lifetime while, in the sense, we're kind of, this is still stack allocated. That's on me. That's my bad. Okay. Doing this here continues the lifetime. Okay. Because it's heap allocated, right? Newing up. It keeps it alive. It keeps it alive. What else should they? Oh, they're adding in the this pointer. Okay. I might actually do that next stream, guys. Okay, because I actually, as a matter of fact, have to delete this animal class. Okay. And create a new class, which is going to be a rectangle class. We're doing another example here, and we're leading into what's called the this pointer. Okay. I mean, I guess I could make it work in this code, but we'll do another example. We'll change it up. Okay. I am going to back this up though, just to kind of speed things up when I'm writing up this code. The new code for tomorrow, okay? The this pointer. You're just gonna have to stay tuned, follow along. The lecture kind of ended a little sooner, but that's okay. I hope you guys learned something today. We're kind of 15 minutes early, but that'll give you 15 minutes of your life, because normally I do 2-hour streams. Johnny I'm so used to saying that all the time. I need a coffee as well. This cup is almost empty. I literally have a sip, maybe 2, if that. Johnny with Bologna&Weiners coding. I appreciate you learning along today. I hope the examples I did today, I hope hopefully you learned a lot. Again, practice the code yourself. I actually didn't do this. You're probably wondering why. Okay, let's do this. Okay, I want to see what happens. All right, before we end. I almost forgot about that. Let's run it. It should still change. I didn't change anything else. Everything's good here, right? Yeah. Weight is 5 here. I could print weight beforehand as well. Let's do that. We're going to do the weight as well. Get weight. And I don't know, we're going to say, I don't know, pounds. I'm just going to say pounds. Is there. Okay? And we'll do a before and an after. Okay? I'm just going to separate this. And then 8 years later, I'm just copying this. And then I'm going to go set weight. Okay? I actually don't have a hard-coded value here. Whoops. And I'm going to go like this, new weight. Okay, good enough. And then I'm going to go like this. And just to kind of save some time, I'm going to go like this. And I'm going to go like this. And you follow what I'm doing. Okay? I'm just going to leave it as 10. Because if you look at... Or maybe I'll make it 11, just so you can see that it's a different value. Okay? If we go here, at 2 years old, Frisky is 5 pounds. Okay? I know, that's a lot. But it's just an example. Who cares? All right? 8 years later, right? Frisky, yeah. Okay? So I'm going to run this. Let's build it. And we should see both. Right? We're doing the before, 8 years later. We're changing the values. I'm using my hard-coded values. Well, actually, my literal constants. They're not hard-coded. I'm using a symbolic constant. And then we're printing. These are the exact same statements, guys. We're just printing a before and an after. That's all we're doing. Let's run it. Let's go. Frisky is 2 years old and 5 pounds. Frisky is 5 pounds. 8 years later, Frisky's 10 years old and Frisky is 11 pounds. Let's go. So if you notice, right, the first set of values it's pulling is from here. Okay. All right, because these are, right, they're the default values if you want to look at it like that. These are default set values that we've kind of hard-coded. And then we changed it in code here. I'm kind of glad this happened so you guys can see this, right? So we changed the values here, right? So we're updating, right? Yeah, we're changing the values, essentially. That's what we're doing. Okay, I'm going to run it again. There we go. 8 years later. Frisky needs a diet. Frisky! All right, I'm leaving at that. Much love, every single one of you supporters, followers. You know how I feel. You truly do. Thank you for all being winners, every single one of you, right? You're all winners. Look at yourself in the mirror, because Johnny says, and say to yourself, I am awesome. That's right. That's how you are. You're in fact awesome. I'll see you guys in the next live stream, or not live stream. Exclamation point. Live. That is it. Johnny with Bologna&Weiners Coding. I appreciate you. I'll see you in the next video. Take care, whoever you are, wherever you are. Have a great rest of your day, evening, noon, or night. And I'll talk to you soon. Take care for now. Peace.
See